Hello and welcome all on Unacademy JEE English, guys. Yes, it is a channel launched by Unacademy, guys, where each and every topic for IDJ will be taught in pure English. And today I'm going to start a new topic, that is chemical equilibrium. So you guys were asking for it for so many days, and today I'm with it. Chemical equilibrium, guys. That's very important. Actually, in NCERT there is only one topic named chemical equilibrium, but we will divide it into two parts: chemical equilibrium and ionic equilibrium, and then we will do it. Okay guys, so first part is chemical equilibrium. It will take 4 to 5 classes, and after that we will take ionic equilibrium. Okay guys, so first let's learn chemical equilibrium today. What do you mean by equilibrium? And does equilibrium applicable only for chemistry? No, even in our daily life we come across so many situations where we encounter equilibrium in our life. So where are those situations, guys? I will discuss each and everything. Okay, so guys, chemical equilibrium is very important topic, and if you want to understand it, you have to visualize it, and visualizing it would be easy because in our daily life we come across many scenarios, many situations where equilibrium comes, not the exactly chemical equilibrium, equilibrium comes. So guys, before we start today's class, let me tell you something about myself. I'm Rahul Kaushik, guys. Yes, I have been teaching in Bansa classes for last 10 years. Yes guys, for last 10 years, 2010 to 2020. And during my tenure there, I was head of department, guys, and I mentored 2000 plus IIT. After that, I co-founded my own organization, Zigyan Education Private Limited. And now, along with Zigyan, guys, I'm here on Unacademy, India's largest and fastest growing online platform, to share all my experience and knowledge with you guys. Okay, so this is all about me, guys. Now, let me tell you guys, we are also there on the Telegram app, and the link for Telegram app is given in the description of this video, guys. Okay, now, guys, I will tell you what are those simple steps which you can use to subscribe to Unacademy, guys. Just go to Play Store. Hi Hariharan. Okay, we will update them very soon. Okay guys, we will update them, don't worry. So guys, there are some simple steps. Using them you can subscribe to it, guys. Step number one, just go to Play Store or App Store and download Unacademy's learning app. Once you have downloaded it, install it, and after installing, guys, yes, you will be reaching onto this page, and on this page, guys, you have to check on the plus. Yes guys, so there was some network issue, now that has been resolved. So guys, I was telling you, once you have clicked on the plus, guys, you will be getting ITJ. Yes, you will be getting ITJ and NEET UG, guys. And once you are getting IIT and NEET UG, then again you have to check the IIT because we are preparing for it, guys. And after this, you have to hit the subscription button. And once you are hitting the subscription button, guys, you will be reaching onto this page where for 2 year, guys, if you are applying my code Rahul Cam, then for 2 year, guys, you have to pay 50,000 rupees for 2 year course, for 24-month course. Okay, just a minute, guys. Yes, now it will not buffer actually. I forgot to connect it to the high speed internet. So there was the issue, right? So now you will not face any issue. Yes, and Triveni, Bragg's equation is not part of IDJ syllabus, so I did not teach that. Okay, guys, Bragg's equation is not part of IDJ. Okay, so guys, now after this is Rahul Camp. This is my code, guys, and if you are applying it, you have to pay 50,000 rupees for 2 year. Now again, let me tell you the fees, guys. The fees for 1 year, is 38,500, and if you are applying my code Rahul Cam, then you have to pay 34,000. Again, this is 56,000 for 2 year, and if you are applying my code Rahul Cam, then you have to pay 50,000. Any doubt, guys? Please ask. Any doubt? No doubt. So guys, this is the fee structure and this is my code. So always remember this code whenever you are applying for it, right? No problem, Triveni. If you leave it, there will be no issues. So guys, now I will tell you what are the advantages. What are the advantages of taking plus subscription, guys? So point number one, you guys will have access to my video lectures and content, and not just my video lecture and content, but the video lecture and content of all the educators who are teaching there for mathematics, for physics, everything, guys. Yes, you will get it. Second point is course would be structured, guys. And once your course is structured, you will get DPPs, you will get modules, so everything will be provided to you. After the question, every fourth class will be doubt clearing session, guys. Hi Alice, every fourth class would be doubt clearing session. So these are all the benefits which you guys can get once you are part of it. Other than this, there would be weekly quizzes. Okay, there would be weekly quizzes. So I hope now everything is clear to you guys. So there are many advantages, and you just have to pay for 1 year. You just have to pay 34,000, and then for 24 months you have to pay 50,400 rupees. Actually, this is beyond my control, Vinay. I can't say this thing. I can't say. I can only talk about my syllabus. Okay, but I will tell about this feedback. Don't worry, Vinay. Yes, I will inform them about your feedback. Surely, I will inform them. Okay, so guys, let's start chemical equilibrium, guys. Let's start it. So, chemical equilibrium, a very, very important topic, guys. Chemical equilibrium. So, what is this, guys? Here, what is this? As you can see, as you can see here, yes, we have a spoon. Yes, and in this spoon we have sugar, guys. Okay. Hello, Aishwarya Agarwal, and this is water. So why I'm taking this example, guys? Why I'm taking it? Can any one of you tell me why I'm taking this example? Is there a specific reason for it? Tell me, guys. So now I will tell you. Now I will tell you, guys. I'm taking this example because in our day-to-day life we generally come across this scenario, and especially in the summers we prepare shikanji, lemon water. So what we do, we take a glass of water and then mix sugar into it and then stir it. And once we stir the sugar, then the sugar will dissolve. And what will happen, guys? Certainly a stage will reach. Certainly a stage will reach. And when what will happen? A stage will reach when all this is water, guys. Suppose I'm taking these are sugar particles, right? A stage will reach when all sugar particles or the maximum sugar particles are dissolved in the water. And once they are dissolved, guys, once they are dissolved, what will happen now? What will happen? Such a sugar solution will be called saturated sugar. Suppose here I am taking 100 gram of water and it can maximum dissolve 10 gram sugar maximum. And now assume I have added 15 gram. So what will happen? What will happen to extra 5 gram, guys? What will happen to that? The extra 5 gram. Tell me, guys. So I'm telling you guys the extra 5 gram sugar will be present at the bottom here, right? And now if you further stir it, suppose I'm having a stirrer as well. I'm having a stirrer as well. Now this stirrer is not visible. Let me take some different. Okay, suppose I'm having this stirrer, guys. So what will happen? Yes, Lokesh, surely you will get. I will update them. Very soon I will update. Okay. So this is stirrer, guys. And if I stir them, what will happen? This 5 gram sugar, will it dissolve or not? Will it dissolve or not? You will say that this 5 gram will not dissolve. But actually you can perform an experiment here. If you are taking a sugar piece like it, if you are taking a sugar piece like it, okay, if you are taking a sugar piece like it and adding here, then after some time you will find that shape of this sugar piece shape of this sugar piece will become like it. Yes, it will become round. So why it will become round? It means the rate at which sugar is dissolving in the water, at the same rate it is being undissolved. At the same rate, guys, it is being undissolved. So here I will tell you guys, here I will tell you that a stage will reach when rate this process is dissolution and the backward process is crystallization, right? The forward process is dissolution and the backward process is crystallization. And what is going on exactly, guys? Yes, let me tell you. If 0.1 gram of sugar is being dissolved per second, so the 0.1 gram of sugar will undissolve per second. And you are thinking that no sugar is being dissolved when this solution has become saturated. So this stage, this saturation state in chemistry, I call this state as, in chemistry I call this state as what? Tell me, guys. Equilibrium. And at equilibrium, you people think that there is no reaction that is taking place, but I'm telling you guys, yes, process is going on, but the rate of forward process has become equal to rate of backward reaction. Okay, guys, are you getting my point? I answer. Process is going on when, yes, when you are stirring a saturated solution, most of you will answer like, sir, there will be no dissolution. No, I am telling you, sugar is being dissolved, sugar is being dissolved, but the rate of dissolution of sugar is same as the rate of undissolution. I hope, guys, you got it now. The rate of dissolution of sugar is same as the rate of, note it down, guys, that's important. Yes, note it down. Okay. So guys, let me take one more example. Let me take one more example. So actually this particular example shows like if I took a cube and I add the cube in the saturated sugar. So what will happen? After some time I will get a sphere, and the mass of cube was 5 gram and the mass of sphere will also be 5 gram. So mass is fixed. And you will think this cube has not been dissolved, but then why mass is fixed? Actually it shows that these corners are being dissolved, these corners are being dissolved, okay, and the same amount of sugar has been deposited or crystallized over it. As a result its mass remain constant. As a result its mass remain constant. So guys, if somebody asks you that at equilibrium nothing happens, that is wrong. Actually at equilibrium both processes happens, dissolution as well as crystallization, but their rates become equal. That's why net force or the net reactions looks zero. Why? Because their force become equal. I hope, guys, you got it. So this is about crystallization and dissolution, and we call equilibrium as dynamic. So it looks static, but it is not static, guys. It is dynamic in nature. Answer: NCRT studies must. For if you are going through my lectures, I generally say, although I cover each and every point of NCRT, but yes, although I cover each and every point of NCRT, but still you should have a habit of reading books. So you should go through the NCRT. You should go through it. Okay? Yes, tell me now. Any doubt? Any doubt, guys? No doubt. So, guys, let me take one more example. Here, guys, this is water and this is copper sulfate. Okay? And if, guys, this is copper sulfate, then what would happen? So, when you are adding copper sulfate, guys, you can see here this is colorless. But after adding the copper sulfate, yes, this has become color. So it means this copper sulfate has been dissolved. But if you keep on adding extra copper sulfate, a stage will reach when this blue color compound will deposited at the bottom, right? And at this stage, you will call in day-to-day life, we people call it as saturation. And what is saturation? At which rate of forward reaction become equal to rate of backward reaction. So we call it as saturation, but in chemical equilibrium we call it as equilibrium. In chemistry we call it as equilibrium. Now equilibrium has been reached, but equilibrium never means that no reaction is taking place. Equilibrium means the rate of forward has become equal to rate of backward. You are taking copper sulfate, it means the rate of dissolution. Suppose 0.1 gram of copper sulfate is dissolving per second. So the same amount of copper sulfate will undissolve per second. As a result, net amount of copper sulfate at the bottom will remain constant, but still it will take place. Okay, guys, and I call it chemical equilibrium. Okay, guys, I call it chemical equilibrium. Tell me, guys, if you have any doubt. Any doubt, guys? Please tell me. Okay. Yes, answer. You can do. Is that done now, guys? So now let's move to the next point. Now let's move to the next point, guys. Yes, and this point is, guys, chemical equilibrium. Because I was talking about dissolution, now I'm taking a chemical reaction. Now I'm taking hi ready. Yes, this class started 20 minutes back, but you have not missed many things. Yes. So guys, now let's start. Here what is going on? Actually, if you can see, here I'm taking N2O4 gas. In this container we have N2O4 gas. Now when this N2O4 gas dissolved, we people get NO2 gas. And guys, this NO2 gas is brown color. This NO2 gas is brown color. And why do I put two arrows here? Why do I put two arrows here? Because one arrow represents forward reaction, another arrow represents backward reaction. Okay, guys. So forward and backward reaction, to distinguish them, I use this. Okay, guys. So what is going on exactly here? What is going on? Initially, you can see this reaction mixture consists of mostly N2O4, and you can see this is colorless. But what happens? Now this N2O4 start dissociating. This brown color, this is compound. This compound shown is NO2. This compound shown is NO2, guys. Let me change the color. Yes. So now what is going on? This is the time t is equal to 0 when reaction was started. After some time, suppose out of 10 molecule, 3 molecule were converted into it. Then after some more time, you can see the watch. You can see the watch there. After some more time, yes, more and more molecules of NO2 are. So what is going on? This N2O4 is converting into NO2, and more number of NO2 molecules are being formed, and the color of NO2 molecule is bright. So guys, after some time you will get a brown color, and initially it was colorless. So it was colorless due to N2O4, but now the brown color is due to NO2. So as number of NO2 ions increases, the color intensity of color will keep on increasing. Here you can see the light brown, dark brown, and the more dark. So what is going on? Again a stage will reach. Again a stage will reach, guys, when when rate of formation of NO2, means the rate at which reaction is moving to the forward direction, will become equal to the rate at which reaction will be moving into the backward direction. Okay guys, a stage will reach, and that stage we call it chemical equilibrium. Yes guys, you can take snapshot of it, you can read it. The brown color deepens as more N2O4 decomposes more N2O, right? Right guys, brown color deepens, and you know the reason. You know the reason. Again guys, the reaction continues in both directions at equal rate. Here we can say that equilibrium has been achieved. So the reaction continues in both directions at equal rate. So the concentration of NO2 and N2O4, and therefore the color no longer changes. As here you can see, as time is proceeding, color is becoming darker, darker, and more dark. But a stage will reach, now this color will become fixed. It will not go up to in more darker side. Why? Because at this point, because at this point the rate of formation of NO2 gas become equal to the rate of formation of N2O4 gas become equal to the rate of dissociation of it. I hope guys you got it. Suppose 0.1 mole is going in direction, so the same 0.1 mole will be moving to the back direction. I hope guys you got it. So same rate of forward, this is rate of forward reaction, this is rate of backward reaction. So rate of forward reaction has become equal to rate of backward reaction. I hope guys you got it now. Okay, so now you have got the equilibrium. So again, this is another experiment which proves that equilibrium is dynamic in nature. Equilibrium is dynamic in nature. It is not static, and we think it is static, it is not. Okay guys, so now again I am moving chemical equilibrium. So what is chemical equilibrium, guys? So guys, here you can see a chemical reaction was taking place. A chemical reaction was taking place, and a stage will reach when rate of forward become equal to rate of backward. At this stage, if I say that concentration of NO2 is zero point 0.1 molar and this is 0.2 molar, then these concentrations will become fixed because they are not changing with the time. And here if you calculate average molar mass of mixture, that will also become constant. So average molar mass of mixture will also become constant, and once your average molar mass is constant, your concentration is constant, what will happen guys? Vapor density will also become constant. Why? Because what is vapor density? It is molar mass divided by 2. So all the parameters like partial pressure, concentration, temperature, vapor density, all parameters will become constant at what point guys? At equilibrium. So note it down this definition as well. So what is equilibrium? It is a state of process at which various measurable properties like pressure, concentration, vapor density. So what is equilibrium? So during a process, it is that state or that stage at which various measurable properties like pressure, concentration, vapor density, etc. these become constant or they do not change with the time at all. Okay, guys. So in normal day-to-day life, we call it as saturation point, but now in chemistry, we call it as equilibrium when rate of forward reaction become equal to rate of backward reaction. So it might happen when you are stirring. It might happen when you are stirring, guys, sugar solution. Yes. So after some time, sugar solution will become saturated and some of the sugar will be present at the bottom, right? So in day-to-day life, we call it saturation point, but in chemistry we call it equilibrium point. Hi Osho, but in chemistry we call it equilibrium point. Okay, Kavya, thank you for your compliment, guys. Yes, but what I'm telling you guys, be regular. Be regular, don't miss any classes. And if you can attend, live classes would be more beneficial because you can ask directly your doubts. Now there are not so many guys over there, so you can directly ask. Yes, I teach at an academy. Yes, I'm there also on the plus as well. On the plus, we also provide you the module, sheet, DBP, everything I'm providing, and I've already covered the mole concept. So you can get the sheets and all those modules. There would be DBPs, there would be live quizzes. Yes, tomorrow also I am taking a mega quiz over the mole concept. So if you are on the plus, then Kavya, you can go there and you can join that. Yes, now I will be starting redox there. The next topic will be redox. Okay, so guys, now let's move. Now you know about the chemical equilibrium. So guys, basically it is the state of a process at which various measurable properties like pressure, concentration, vapor density, etc. become constant or they do not change with the time. Okay, not an issue if you can, because you might be having some doubts when you are studying, so those doubts can be cleared. Okay, guys. So guys, now what are the points which I'm going to cover in next few classes? What are those points, guys? Yes, after you have studied this chapter, guys, you should be able to, point number one, explain the basic idea of chemical equilibrium. Yes, what are the objectives of this chapter? After this, guys, you will be able to explain what an equilibrium constant is and what it tells us. So what is equilibrium constant? I will tell you. We denote it by K. Generally Kp, Kc, these are equilibrium constant. And what are the physical significances of equilibrium constant? If you know the value of equilibrium constant for a particular reaction, then what does it indicate? Then you will also be able to explain the meaning of reaction quotient and what reaction quotient will tell you. So right now I'm telling you what are the points which we are going to cover in this chapter. Okay, next one is you can use this equilibrium constant. You can use this equilibrium constant to find various parameters, various parameters like concentration, like partial pressure, etc. Total pressure. So you can use this equilibrium constant to find out various parameters. Okay. Hi, Amy. After that, guys, now I'm talking about the things which we are going to cover in next few days. Okay, and the next point is, guys, next point is you will be able to recognize the factors that affect equilibrium. Means what are those factors which affect equilibrium? Like if a chemical reaction is taking place, if a chemical reaction is taking place, right? You are getting PCl3, Cl2 and PCl5. So if I add extra chlorine, then what will happen? If I add extra PCl5, then what will happen? If I add extra PCl3, then what will happen? So these are all the factors, guys. These are all the factors which will tell you, guys, in which direction the reaction will move. What will be the impact of changing the concentration? What will be the impact of changing the temperature, partial pressure? So each and everything you guys are going to cover. After this, KP and KC I am already discussed. There will be relationship between thermodynamic and equilibrium. So how many of you know? How many of you have already studied the thermodynamic? Yes, guys, can you tell me? How many of you have already studied thermodynamic, guys? Tell me. Okay. So, guys, again, you can estimate equilibrium constant at different temperatures. You can estimate equilibrium constant at different temperatures. So there will be a relationship. Okay, how many of you have done thermodynamic? Tell me, guys. How many of you have done it? Tell me, guys. Alice has done it. And who else? Only Alice has done it. Okay, I will take thermodynamic after it if you want. But many students are asking for chemical bonding. So I'm planning to take chemical bonding and then we can take thermodynamic. Okay, guys. Okay, very good, Alice. So, guys, now there are two types of equilibrium. One we call as physical equilibrium, another we call it chemical equilibrium. So there are basically two types. One is physical and another is chemical equilibrium. Okay, so I will discuss what type of equilibrium physical is there. So chemical equilibrium is further of two types: homogeneous equilibrium and heterogeneous equilibrium. Good afternoon, Sankaran. Good afternoon. So guys, you can write down here. Chemical equilibrium will be further two types: homogeneous and heterogeneous. And then here we have physical equilibrium. So what do you mean by physical equilibrium? So guys, I'm telling you the physical equilibrium we were already taking, like solid liquid equilibrium. So what is solid liquid equilibrium? So suppose I'm taking ice and this ice is melting and getting converted into water. So I will call this equilibrium as solid liquid because this is the equilibrium sign, and at equilibrium the rate of formation of water will be equal to the rate of formation of ice. The same amount of water molecules are converting back into ice. Ice is melting into water. This is solid liquid. Similarly, guys, we can say solid gas. Solid gas equilibrium. So example for this is CO2 solid, and in the room temperature it will be converted into CO2 gas. So this is solid liquid equilibrium. This is solid gas equilibrium, and now I will talk about liquid gas. So all these equilibriums come under physical equilibrium category. Okay. Yes, ionic equilibrium is type of chemical equilibrium. Right. So in liquid gas, what will happen? Suppose you are heating the water, then at boiling point it will get converted into. There are other types of it as well. Now I will take it here. Now I'm taking solid solution. So what is solid solution, guys? So it is, again, you can take NaCl plus water and it will give you NaCl aqueous. So this solution can be saturated, or you can say sugar plus water. This is basically salt, namak, and it will give you aqueous solution of sugar. So what will happen at equilibrium? I have already discussed with you guys. At equilibrium, what will happen, guys? This sugar is dissolved in the water, so the rate of dissolution will become equal to rate of crystallization. So in physical equilibrium, no chemical reaction will take place at all. However, in chemical equilibrium, these are of two types, homogeneous and heterogeneous. I will discuss them later. But in homogeneous, there will be chemical reaction. In heterogeneous, there will be chemical. So what is the difference between physical and chemical equilibrium? So here there will be no reaction, and in this case there will be a chemical reaction. There will be a chemical reaction, guys. Okay, now tell me, got it? Guys, there is one more equilibrium. Like here I have dissolved the solid in solution. I can also take gas in solution. Gas in solution. Guys, here we can also dissolve a gas. How we can dissolve a gas? Henry's law I will teach you in 12th class when I will be teaching you the liquid solution. Definitely I will be taking that. But right now I will also tell you something about it. So just note down the chemical equilibrium is of two types, homogeneous and heterogeneous. No, first I will teach you chemical equilibrium, then separately I will start ionic equilibrium, but surely ionic equilibrium will be started after it, once chemical equilibrium is over. Okay guys? Yes. Are you getting what I'm saying? So guys, gas in liquid solution, what will happen? Now I'm telling you. This is a piston, guys. And here I'm taking the water. This is the water, guys. Suppose some gas particles are here. And suppose I'm taking O2 gas. So when I'm applying pressure, some O2 gas particle will be dissolved in the water as well. And if I'm adding the mass, or if I'm increasing the pressure, what will happen? More and more gas particle will collide with the water surface, and more particle will collide with the water surface, guys. As a result of which, what will happen? Yes, guys. What will happen? More and more gaseous particle will be dissolved. And if more and more gas particle will be dissolved, guys, M2, M1, I'm increasing the pressure here. So what will happen? A stage will reach when rate of dissolution of these particles will become equal to rate of undissolution. So again there is a equilibrium. Again there is a equilibrium. So if you increase this pressure, more and more particles will be dissolved. Okay, and if more and more particles are dissolved, guys, what will happen? You will say that more and more gas is dissolving, solubility is increasing. So on increasing the pressure, solubility of gas will increase inside the water. So this is also a case of physical equilibrium. Why it is a case of physical equilibrium? Initially there was O2 gas. This was O2 gas. When you are adding it into water, then it will become O2 aqueous. So this gas we call it as dissolved gas. Yes, guys. This is dissolved gas. Okay. Have you done it? So guys, now you know the difference between the dissolved and undissolved gas. Tell me if you still have any doubts. Tell me, guys. No doubts? So let's move ahead now. Let's move ahead now. So now I will tell you about the chemical equilibrium, guys. So chemical equilibrium is further two types, homogeneous and heterogeneous. And in chemical equilibrium, guys, what will happen? In chemical equilibrium, there will be a chemical reaction. So what is homogeneous equilibrium, guys? What is homogeneous equilibrium? So let me tell you guys, in homogeneous equilibrium, phase of all reactant and product will be same. Phase of all reactant and product will be same. So let me write some examples. Suppose I'm taking H2 gas, I2 gas, giving you 2HI. So everything is in gaseous phase. So it is called homogeneous equilibrium. If I'm writing NaOH aqueous, HCl aqueous, okay, instead of it, let me write something else. NH4OH aqueous and CH3OH aqueous, CH3COOH aqueous. So what will happen, guys? You will be getting plus H2. So guys, here everything is liquid. So this is homogeneous phase. Now what is heterogeneous phase, guys? What is heterogeneous? So in heterogeneous, I can take it like this. Here you can observe these two are solids, but this is gas. So it will be heterogeneous. So what is homogeneous? What is homogeneous, guys? Note it down. What is homogeneous? In homogeneous, more than one phases will be present. Sorry, in heterogeneous, more than one phases will be present in reaction. So you can take the example of it. And what is homogeneous? Note it down, guys. Note it down. In homogeneous, all the reactant and product will be present in the same phase or single phase. All the reactants and products will be present in same phase. Note it down, guys. All the reactants and product will be present in same phase. And just note down these examples. I can give you one more. If I'm taking PCl5 gas, it is converted into PCl3 gas and Cl. Okay, so this is also case of homogeneous. This is also case of heterogeneous. Yes, guys, tell me. If you guys have any doubt, please ask. No doubt. So now it is clear that chemical equilibrium will be two types, homogeneous and heterogeneous. And in chemical equilibrium, a chemical reaction will take place. If guys this is done now let's move ahead. So again, what are the types of reaction? So guys, there are two types of reaction. One type of reaction we call them reversible, another type of reaction we call them irreversible. So what is reversible reaction? So guys, these are the reactions which go up to completion. So guys, these are the reactions which go up to completion. It means almost 100% or most of their reactant will be converted into product. And let me take one or two example of it. If I'm taking reaction between acid and base, so I will be getting NaCl aqueous and H2. Okay, so guys, this is example of irreversible. Sorry, I'm explaining irreversible here. This is irreversible, and here I will take reversible, not an issue. So in irreversible reaction, the reaction which go up to completion, I will call it irreversible. So in this case, if I have taken 1 mole of it, then after the reaction you will get 1 mole of. Okay, now what is reversible, guys? So in reversible reaction, all a reactant will never get converted into product. And how? So just note it down. In reversible reaction, these reactions do not go up to completion. For example, why they do not go up to completion? Let me take one example, guys. Suppose here, guys, I'm taking PCl5 gas. Okay. Now, once your PCl5 gas is decomposed, it will give you BCl3 gas and Cl2 gas. So once you are getting it, guys, so in your container, when equilibrium will be reached in your container, what will happen? You will have a mixture of BCl5, BCl3 and Cl2. Okay. Suppose at T is equal to 0, you took 1 mole of it. So 0 mole were it. But after some time equilibrium will be achieved. So this is the time after which equilibrium is achieved, and now suppose there are 0.8 mole of it. So you will have 0.2 mole of it, you will have 0.2 mole of it. Now what will happen? Suppose you have started this experiment at 10 am. Equilibrium was started at 10:30, was achieved at 10:30 am. So guys, again if you will see this at 11:30 am, you will find the same composition. Okay, if you will see it at 1 p.m., you will find the same composition. So guys, we will have zero point 0.8 mole of it, 0.2 mole of it, 0.2 mole of it, and all these three reaction components, are in equilibrium. Okay guys, and if they are in equilibrium, then I told you that at equilibrium there will be no change. At equilibrium there will be no change in the composition or in the concentration or partial pressure of reaction components. So guys, tell me if you have any doubt. Yes, Alish, Prem Kumari, Pram Kumari, anyone? No doubts at all. So now I hope you guys are getting what is reversible reaction, what is irreversible reaction. So now you know the difference. Irreversible reactions are those which will go up to completion, and reversible reactions are those which will not go up to completion. Got it? So note it down, guys. Note it down, all the examples I have taken. Once you have done it, so your reversible reaction is over. Similarly, I can take one more example. Suppose if I am taking N2O4 gas, it will get converted into NO2 gas, right? So it is again a case. Yes, here you will have N2O4, and this N2O4 gas is colorless, right? So once your equilibrium is achieved, guys, it will be brown color. Why it will be brown color, guys? Why? Because this is brown, right? And this intensity of brown color will become constant when equilibrium will be achieved. Any doubt, guys? Please ask. No doubt. So irreversible reaction, these are the reactions which goes up to completion. So let me take one more example. Yes, so acid base reactions, especially if one one of acid or base is strong, their reaction will definitely go up to 100% complete. Okay, so in acid base reaction, if I talk about it, suppose I'm taking HCl aqueous, I'm taking NaOH aqueous, it will give me NaCl aqueous plus H2. So this is moving up to 100%, right? So I'm saying because it is going in the 100%, now you cannot reverse it. Once this is over, all the reactant, suppose I'm taking 1 mole, I'm getting it. Similarly, we can also take precipitation reaction. So once a precipitate is formed, you cannot convert it into its reactants. Suppose I'm taking AgNO3 aqueous and KCl. It will give you AgCl solid plus KNO3 aqueous. So guys, this is the precipitate form, and once this precipitate is formed, you cannot revert it into AgNO3 and KCl. That's impossible. And this reaction will again move to 100%. Actually, in this world, nothing is perfect. Nothing is perfect, so never they will go to 100%. Although they moves to 99.99%, we consider it as 100% because that 0.01% is useless for us. We can say it is almost 100%. So acid-base reactions are generally irreversible. Precipitation reactions are generally irreversible. There is one more case, decomposition reactions. Decomposition reactions. So guys, suppose I'm taking here CaCO3 solid and I start heating it. What will happen? So when you heat CaCO3 solid, it will get converted into CO solid and CO2 gas. Okay. So after the reaction, this is solid, this is solid, this gas will escape. So you will be left with CaO only. You will be left with CaO only. So guys, this is again irreversible reaction. Why? Because the CO2 gas form is escaped. Now, if you want this reaction to go back, you need CO2, but all CO2 gas has been escaped. So how can I revert it? It is impossible, right? But guys, we can do one thing. We can do one thing. And what is that thing, guys? If I close this container, if I close this container, if container is closed, then what will happen? If container is closed, guys, then this reaction will become reversible. Now you can see what I'm doing. I'm using this sign for reverse. I'm using this sign for irreversible. The single arrow I'm using it for irreversible, and for reversible reaction I'm using the double arrow. Yes, because when you will close the container, the CO2 gas will not escape, and this CO and CO2 will again, they can again react and they can again form the CaCO3. Because what will happen in the container, if I'm having CO here and CO2 gas here, they will, if there is excess CO2, then what will happen, guys? It will again combine with CO. The CO2 will combine with CO and they both will come to form CaCO3. Okay, yes, it will not escape. It will not escape at all. So now you are getting CaCO3 giving you CO and CO2 gas if your container is closed. Okay, similarly you can take one more case. Three Fe solid, you will be getting. So guys, what is this going on? Now I'm telling you, suppose this is the container, and in this container I'm taking it as Fe solid, and from this end I'm passing the steam. Why I'm calling it steam? Because these are vapors of water. This is not exactly water. So guys, when I'm passing steam through it, what will happen? Hydrogen gas will escape. If this is open, hydrogen gas will escape, and you will be finding Fe3O4, right? Once you are finding Fe3O4, guys, what is going on? Hydrogen gas will escape. So guys, if this container is open, it means reaction is irreversible. And if you close this container, then it will become reversible. Why? Because if you close this down, this whole H2, will get collected here, and this H2 gas and Fe3O4 will again react and they will form Fs. So guys, from these two cases, I can say one thing for sure, that we can convert a reversible reaction into irreversible and irreversible reaction into reversible. So you just have to take into consideration your vessel. So if gases are involved and you want to establish an equilibrium, then you have to take the closed container only, right? Then you have to take the closed container only. So equilibrium for gases can be done only in the closed container. Okay guys, so did you get it? Tell me now. Tell me guys if you have any doubt. No doubts? Okay. So now I will be moving ahead, guys. Now I will be moving ahead. Yes, this is how equilibrium can be achieved between, here you can see this is liquid, and suppose I'm taking oxygen gas here. Suppose I'm taking oxygen gas. So these are the oxygen molecules which are in gaseous state, and these are the oxygen molecules which are in aqueous form. It means they are already dissolved. Okay guys, I think you got it now. Got it? So you will be having O2 gas, you will be having liquid and O2 gas. Any doubt? So if you are increasing the pressure, suppose here it was 1 atm, now it is 1.5 atm, and now it is 2 atm. So more and more molecule will dissolve. So as you increase the pressure, more and more number of molecules will dissolve. Okay guys? And if more molecules are being dissolved, you can say on increasing the pressure, solubility of gas is also increasing. Let me take one more practical example of this. Yes, I will teach you the Henry's law. Henry's law in 12th I will take liquid solution. Okay, and Henry's law says that solubility of gas is directly proportional to pressure. Henry's law says solubility of gas is directly proportional to pressure. If you guys are going to increase the pressure, then solubility of gas will increase. Okay, yes, tell me now. So now let's move gas in liquid solution. One more example, guys. As you can see, this is the cold drink, and you might have seen when you pour the cold drink in a glass, you find these bubbles. So why do you find these bubbles, guys? Can any of you tell me? Why do you find these bubbles? Tell me, guys. Any answer? So now I will tell you guys what is going on. So here this is the CO2. Sorry, here this is the liquid. And in this liquid I am taking CO2 gas here. So these are the CO2 gas molecules. Yes, you can see them here. And all CO2 molecules are here. So suppose there is a pressure of 20 atm. I just told you that as we increase the pressure, solubility also increases. So in atmosphere, yes, as we increase the pressure, solubility of gas increases. right? So yes, Paris, this is today's first lecture, so it would take 4 to 5 lectures. Chemical equilibrium will definitely take 4 or 5 lectures, right? And then we can move ahead. So if I'm taking this CO2 gas, if I'm taking it, more and more CO2 gas will dissolve if pressure is high. Okay, so suppose at 1 atm pressure, at 1 atm of CO2 pressure, we can dissolve 1 gram. So at 20 atm, I have dissolved 20 gram CO2. So suppose 20 gram CO2 is dissolved in this bottle. So what will happen now? Once I open the cork, this pressure 20 atm to it reduces 0.01 atm, because in atmosphere only 0.001% oxygen is there. Almost, I'm taking some rough data. So instead of 20 gram, 0.01 gram will be left. So 19.99 gram will go to atmosphere. And once this CO2 gas will escape, it will take some water molecules along with it. And when it takes water molecule, these bubbles are formed. So guys, if you keep open cold drink, if you keep this cold drink open for some time, then what will happen? Then what will happen? Tell me guys. If you keep this cold drink open for some time, then all CO2 will escape and your taste of that cold drink will become dull. Okay? Yes, Ryan Faris, Bragg's equation is not part of your syllabus, IIT, JEE or NEET or anything. So I did not teach it. Okay? Yes. Yes, Alice, gas will move in the atmosphere. I hope you got it, guys. So now I'm taking 1 atm of it. So now you got the point, guys. I hope now you got it. Got it, guys? Any doubt, guys, please ask. No doubt. So guys, now let's move ahead. Yes, the gas in liquid solution. Now this is clear to you. When you are dissolving a gas in the liquid solution, so when you open this cold drink, why these bubbles are formed? So these bubbles are formed, it means CO2 gas is escaping. And when that gas escape, it takes up some water molecules and you find these bubbles. You find these bubbles. Okay, guys. So for 1 hour or so, guys, I have been constantly teaching you what is equilibrium. What is equilibrium? Then I told you what types of equilibrium are there. What is physical equilibrium? What is chemical equilibrium? So how will you distinguish between physical equilibrium and chemical equilibrium? Tell me, guys. How will you distinguish them? Physical and chemical equilibrium. Yes, guys, be fast. How will you distinguish them? I'm getting no answers. Is there any way to distinguish them? Yes. In physical equilibrium, guys, there will be no chemical reaction. Like H2O solid is converting into H2O gas. This is physical equilibrium because the molecule on the left are same as the molecule on the right and there is no chemical reaction. And what will happen in chemical equilibrium, guys? In chemical equilibrium, there will be a reaction. There will be a reaction. Okay. So conversion of ice into steam or conversion of ice into water. These are all examples of physical equilibrium. Again, if you are taking NaCl and adding it into water, so you are getting NaCl, of course. So compound is not changing. If you are taking sugar and mixing it in water. So you will be getting, I hope you got it now. All phase transformations are considered. Note it down. All phase transformations are physical change because because there is no change in the chemical compound. Got it? So these are the chemical change because on the left side and on the right side we have different chemical compound. Their identities are totally different. Okay, I hope you got it, guys. Got it? Done. So now I'm moving ahead. So guys, what are the characteristics of equilibrium? Yes. What are the characteristics of equilibrium? Can any of you tell me? What are the characteristics of equilibrium, guys? Anyone? So the first characteristic is equilibrium is dynamic in nature. Dynamic means suppose I'm holding this pen and I'm applying pressure from both sides. So the net force on this pen is zero, but force is not equal to zero. Net force is zero. So why I'm saying dynamic? When equilibrium is achieved, process has not stopped. Process has not stopped. Yes, the rate of forward and backward reaction become equal. If this, let me take it. So guys, what will happen when your equilibrium has been achieved? T is equal to equilibrium. At equilibrium, rate of forward reaction become equal to rate of backward reaction. It means if if zero point 0.1 mole of PCl5 per second is converting into these two, then 0.1 mole of PCl5 per second will get converted into it. Okay? Yes. Not KF, KB, RF, RB. Rate of forward reaction as well as rate of backward reaction. KF, KB are different. Yes, you can go through my chemical kinetics lectures. There I've explained KF and KB in detail. Okay guys, I've explained KF and KB in detail. Any doubt, please ask. Yes, tell me guys. So guys, equilibrium is not static. At equilibrium, it seems that the concentration, suppose at equilibrium, its concentration become 0.5 molar and it's become 0.2 molar and concentration of this become 0.2. So you will think like, sir, at concentrations are constant, so no reaction is taking place. No, it is not like that. Chemical equilibrium is not static. Reaction is taking place, but the thing is this, that rate of forward reaction is become equal to rate of backward reaction. Okay. Actually, Rayan Ferris, I don't teach organic chemistry. I will give your feedback to the management, don't worry. And I can teach you only physical and inorganic. So there is no point in writing me over and again. I have already conveyed you your message, guys, and I will again convey it. Okay, Rayan? So guys, equilibrium is dynamic in nature, and at equilibrium rate of forward reaction become equal to rate of backward reaction. So now let's move to the next point. What are the characteristics of equilibrium? So I've already told you. Second characteristic is the rate of forward process at equilibrium is equal to rate of backward process. Note it down. So rate of forward This is rate of forward, this is rate of backward. So they have become equal at equilibrium. Okay guys, just note it down. So if it is moving 0.1 mole per second, 0.1 mole. So zero point 0.1 mole of A is being formed into or converted into B. The same amount of B is converted back into A. Got it? Tell me guys. So guys, third point. What are the characteristics I'm teaching? There are two characteristics we have already done. One is it is static in nature. It is dynamic in nature. Second thing is rate of forward reaction become equal to backward, and the third point is all measurable properties, like concentration, vapor density, like partial pressure, and you can take temperature, everything which you can measure become constant, and looks like that reaction has stopped, but it has not stopped. Okay guys, so all measurable properties remain constant over time, and the state of chemical equilibrium is characterized by equilibrium. So I will discuss this point. What is equilibrium constant? Don't worry, I will discuss it. So the next point is equilibrium can be achieved from both directions. What do you mean by it? Equilibrium can be achieved from both directions. What do you mean by it? How? So I'm telling you guys, suppose I'm taking here in the container BCl5, 1 mole. Okay. After some time, I will find that this BCl5 decompose into PCl3 gas and Cl2 gas. At T is equal to 0, if I was taking 1 mole, it was 0, it was 0. Then after some time guys, it will become suppose 0.8 mole when equilibrium has been achieved. So suppose it becomes 0.8 mole, 0.2 mole, 0.2 mole. Yes, Abhi, I teach. No, I don't teach in any batch, I teach independently. Very soon we people are going to launch English batch. Currently I'm teaching mole concept there. Today is last class, idiometry will be over today. So guys, at equilibrium what you will find? At equilibrium in the container we have all three gases. That PCl5 is 0.8 mole, PCl3 is 0.2 mole, Cl2 is 0.2 mole. All three gases are there. So in this case what I did, I took the 1 mole of PCl5 and then I established the equilibrium. Now somebody might ask, sir, if I take 1 mole of it, 1 mole of it, if I take 1 mole of it and 1 mole of it, yes, and 0 mole of it at T is equal to 0. So can equilibrium be established? Now what will be the answer to this? What will be the answer to this guys? So this time I'm taking the product side. So yes, answer will be yes sir. Equilibrium can be still achieved. So and once we will achieve equilibrium, I will be getting 0.2 mole, 0.2. And got it? Got it guys? So now equilibrium can be achieved from both directions. If you take BCl5 in the container, then you will get all three gases. And if you take PCl3 and Cl2. Then again you will be getting 0.8 mole. Okay, so what I want to tell you guys, that equilibrium can be achieved from both sides. You can take these two. Again, reaction will not go up to completion in any case. Okay, Abhi, you can join that batch. Today 7:30 p.m. you can follow me there. Okay, got it? Got it, guys? Any doubt? So, guys, now the point number 5. Again, what is the role of catalyst? So, the catalyst has no effect on the equilibrium. If you are using the catalyst, guys, it will not affect equilibrium. How? So here, guys, if this equilibrium is achieved and I'm having zero point 0.8 mole of it, zero point 0.2 mole of it, zero point 0.2 mole of it. Okay, so what will happen if I'm using catalyst in this reaction? What will happen? What will happen? Then, guys, even after, even after using it, equilibrium concentrations will not change. It means here I can say, that catalyst is having no effect on the equilibrium. Okay, so it will not affect equilibrium concentration, equilibrium partial pressure, vapor density, M average, anything. If you are using the catalyst, guys, it will not affect anything. Yes, but it will do one thing. It will help in achieving the equilibrium quickly. Note it down. It will help in achieving equilibrium quickly. So initially, guys, suppose if you perform this experiment at 10 a.m. and equilibrium was achieved at 10:30 a.m. But if you are using the catalyst here, then you can achieve it at 10:10 a.m. Equilibrium can be achieved. So equilibrium will help you in achieving equilibrium quickly. So catalyst will help you in achieving equilibrium quickly, but it will not change the concentration of reactants and products. It will not change the concentration of reactants or products. Okay, guys, I hope you got it now. Got it? It is never going to change. So this is all about equilibrium. Now the next point and last point. So now you know about catalyst, what catalyst will do and what it will not do. So it will not change the concentration, partial pressure, vapor density, molar mass, but it will help in achieving equilibrium quickly. But next point, guys, if gases are there, then for the gases, equilibrium is possible only in closed container. I have already told you guys. Suppose here I am taking CaCO3 and I heat it. This CaCO3 solid will get converted into CO solid and CO2 gas. And this CO2 gas will escape. So finally in the container I will be finding Ca only. And because the CO2 gas is not there, now they can never combine. Why? Because the CO2 gas formed has been escaped. So again, if you are closing it down, So this CO2 gas will be here, and they will react with each other and they will make CaCO3. So guys, if you want to achieve the equilibrium, then container has to be closed. Note it down, guys. If your container is not closed, then equilibrium cannot be achieved. So in case of gases, guys, equilibrium can be in case of gases equilibrium can be achieved only if container is closed. However, if there are liquids, suppose I'm taking CH3COH, so it will decompose into okay. So this acetic acid is converting into these. Now what will happen? This equilibrium can be achieved in open container. Why? Why, guys? Now I'm telling you, because in this case no gas is involved, everything is liquid. Initially there was only CH3COH, but once the equilibrium is achieved, I will be having this. I don't have any idea, Russell, about it. I don't have any idea about it. If they are launching, then I will very soon I will also let you know. Okay, guys. So all three ions will be there. Okay, guys. All three ions will be there. So guys, this is all for today. Next class I will start with a quiz. Next class I will start with a quiz, guys. So get ready for that. And once I will be starting the quiz, guys, yes, I will ask you the doubts over today's class, whatever I have taught you, guys. And after that I will take law of mass action. What is law of mass action? Why do we need it? And Gulberg and Vaje, why I'm taking their names? So I will discuss. Yes, Ars, you can go through my lecture today. The complete lecture, you will get answer to this question. Because, yes, because it was 90 minutes. Tomorrow I am going to start surface chemistry. In 12th class, I am going to start surface chemistry. So get ready for that. Okay, guys. So in next class, guys, there would be many new things. There would be many new things you guys would study in the next class. Okay, guys. And now, if you really like today's class, guys, if you really liked it, then please share it and like it as much as you can. Yes, that's important, so that your friends can also learn from it. And click on the bell icon, so that you guys can get latest notification of our lectures. Okay, guys, that will help you in getting quiz going, that will help you in getting your plus subscription at a lower rate. Further, they might have planned to do this. Okay, Russell. So, guys, we are also there on the Telegram, and the Telegram, our channel name is JEE underscore English, and you can join our channel, guys. And the link for that channel is given in the description part of this video. Okay, so guys, there are some simple steps which you can use. To subscribe Unacademy. Just go to Play Store or App Store, download Unacademy's learning app. Once you download it, install it. And after installing, guys, yes, click on the plus. So once you are clicking on the plus, you will be getting IIT NEET UG. So check the IIT box, because we are preparing for it. And after this, guys, hit the subscription button. And once you are hitting the subscription button, then for 24 months you have to pay 50,000 rupees if you are applying my code Rahul Kaushik. Remember this code, guys, it's very important for you. Remember this code, because for 1 year you have to pay 38,000, for 2 years you have to pay 56,000. But if you are applying my code, then instead of 38,000 you have to pay 34,000, and instead of 56,000 you have to pay 50,000. Okay, guys. So I'm also teaching on the plus. I'm also teaching on the plus. Then click on the Rahul Camp, use this code, and you will get the 10% flat discount. For 1 year you have to pay 34,000. For 2 year you have to pay 50,000. Okay guys, and I'm also teaching on the plus guys. So there are many advantages on the plus. The course on the plus would be purely structured, and along with the structure you will get regular quizzes there. There would be live quizzes, there would be DPPs after every class, there would be modules, so everything would be there guys. And guys, the most important part is the testing part. You will you will have a chance, or you will give the regular test, then you can assess your performance with respect to your competitors. So these are all the benefits, and along with it you will get access to not just my video lectures, but the video lecture and content of all the educators who are already teaching there. Okay guys, so this is all for today guys. I will again meet you tomorrow, and with so many new things, so many new concepts. So guys, take care of you. Bye bye.